Good morning and welcome to Going to Work with Gena, which is an inspiration for STEM students. I'm Dr. Gena Henderson. This morning, STEM students, I want to talk to you about the compiler versus an interpreter. Remember, yesterday we left off, I was explaining the compiler takes in source code, and through that source code that goes into the computer turns the source code, which is our instructions, which is our readable code, human text that you put in, it turns it into machine code, which is zeros and ones, binary numbers. So with all of that being said, I thought I should go in and tell you that programming languages, high-level programming languages, have a compiler and interpreter, okay? So a compiler, let me tell you the difference between a compiler and interpreter. A compiler converts entire source code. So it takes all of it and it reads it all at one time. And basically, if everything is not correct, you'll just get an error message, okay? So you're debugging for a compiler is very hard, and you have to actually go back to debug it using modules. Whereas an interpreter, you can run it line by line. It executes line by line, okay? Also, a compiler takes a large amount of time to actually to debug, to actually make the program run, whereas it takes less time to interpret and analyze when using an interpreter. Like I said again, it generates an error message, if it doesn't work. Debugging here is a lot easier because you're going line from line, so you're going to instantly know where you've actually messed up. Also, a compiler takes the source code, turns it into intermediate object code, and then which is like the code that the computer turns it into, and then it converts it out to machine code. Whereas an interpreter don't have any intermediate object. It just goes straight through executing. Okay, so with that being said, that's the difference between a compiler and an interpreter. And I thought I needed to go into that a little bit more than I did yesterday. So now I want to jump into programming syntax, because remember, programming syntax is the instructions that you're going to get regardless of any programming language that you use. So when it comes to writing a program, there are 5 elements that must be essential, okay? And that is, you're going to have input, you're going to have output, you're going to have arithmetic, you're going to have conditions, and you're going to have looping. Okay, so input is nothing but getting that data into the machine, into the computer. And then the output is the results, okay? Arithmetic is when when you're adding things together. Conditions are how you test or search for things. And looping is how you cycle through the instructions again, okay? So those are the 5 elements of programming, okay? So depending on which programming language you're going to use, the syntax is going to be different. For instance, I know we'll be using Python, and Python uses an indentation method, okay, as it goes through line by line. And Python is available on most operating systems too. It's easy to learn, it's easy to read, it's very user-friendly. So I think we're going to start out, I know we're going to start out with Python. So I want to thank you for going to work with Gena this morning. If there are any infomercials that you've missed, please don't hesitate to go to YouTube, Going to Work with Gena. Thank you.